In this video, I'll show you how to submit a job to the ARCC clusters using a Slurm script. Slurm is the workload manager used by the ARCC clusters, and instead of running computations directly on the login node, we submit jobs to Slurm, which assigns our job to a available compute node. Now let's go ahead and look and see what this looks like. As you can see on my screen, I have two files. I have a Python script, which is our source code, and then we have a Slurm script. First off, let's go ahead and have a look at this Python script. As you can see, this is a very simple Python script. It just has a couple of print statements. And our goal for today is to take this code and deploy it over on a compute node. Now, the way we do that is through this Slurm script over here. So let's see what's inside of this. Let's go ahead and break this line by line. So the very first line, this is called shebang. And what it does is it turns this text file into an executable bash script, meaning that we gain the ability to call this file, and then every single one of these lines will get executed one by one until we reach the very final one or an error. This is only available because of this line over here, so make sure this is always at the top of your Slurm script. Following up, we have this block of comments, which this is how you write a comment inside of a Slurm script. You just do hashtag followed by space and then the text that you want to comment in. Now moving on, we get to this area over here, which, well, this might look like comments due to the hashtag symbol. They are not comments. These are called Slurm directives, and this is how you're going to ask for resources for your code. So for this Python script, we're requesting 4 CPUs, 2 GB of memory, for a total time of 1 hour. Now, something that is worth mentioning here is this time variable. If you were to leave this empty, by default, Slurm allocates 1 hour to your job, meaning that once this 1 hour hits after you submitted your code, your job will get killed. So what you need to do, and keep in mind rather, is if you think your job is going to take 1 hour, you should be requesting a little bit over that. So maybe request 1 hour and 15 minutes or 20 minutes, just to avoid your job getting interrupted too early. Now, keep in mind that doesn't mean you should be requesting for a very large amount of resources, specifically time, because if you do so, Slurm will take longer to deploy your job. The more resources you ask for, the longer it's going to take for Slurm to find an available node that has those resources available for you. So you don't want to request things that you do not need, because you'll end up waiting longer. Now, also on the other side, you don't want to request too little resources to get your job out there, because then it might get interrupted too early, or you might not have enough CPUs and stuff like that. So what you should be getting away from this is that you need to play around with these settings and figure out a good middle ground for what you need. Now moving on, we have this block over here where we load the modules that this Python script needs to run. So in this case, we're doing module load Anaconda. And then using the Anaconda module, we activate a base environment. Now, obviously, this could get replaced by any other environment that you've created, but for the sake of the example, we're just using base. So in here, you can load your module and then use it. Something else, this up here, the order does not matter for these. You can, place these however you wish. But for this section over here, you should always module load first and then use that module. Otherwise, you'll get an error. Finally, the last section of a Slurm script will always be actually running your code. So a quick recap of what is going on here. The very first line, bin bash, shebang. This will turn this text file into a bash script, which allows us to run every single one of these commands in here one by one, simply by calling on this file. These are comments. Over here, we have the Slurm directives where we request resources. Then we have the area where we load all our modules and then use them. And finally, just running your source code. Now, let's go ahead and submit this Slurm script. So you can submit a Slurm script using the sbatch command, followed by the name of the Slurm script. In doing so, we get this output message, submitted bash job, and then we're given a job ID, which we can use to track our job. So let's go ahead and see the status of our job. We can do so by typing sq-me. And the job will not show in here. And the reason for that is that this Python script was already finished. It took a very short amount of time to get finished. So we won't see anything in here, but in the case that you do submit a job that takes, let's say, multiple hours or couple days, you'll be able to track it in here. It will show up and it will give you some stats on it. Again, this is done with sq-me. But since our job is finished, we can go ahead and take a look at the output, which appeared in the same folder that we submitted the Slurm script in. So if we do cat slurm, also note how this is your job ID. So in the case that you have multiple .out files, you'll be able to differentiate in between them using the job ID. So let's see what's inside of this. And over here, we have the output of our Python code. It just prints hello Python. Then it says running on node EC108, which it looks like Slurm looked at all of the Slurm directives we requested, the 4 CPUs, the 2 gigabytes of memory, and the 1 hour, and decided that EC108 would have these resources available for us. So it deployed our Python script on EC108. And then, again, we get a confirmation on how many CPUs we asked for, which, as you can see, if you remember, we asked for 4 CPUs using a Slurm directive, and this is what Slurm gave us.